One question I've gotten repeatedly is why don't we just stick windmills on our electric cars as we drive to charge the car so we don't have to use any power? Well, let's try it and see if this works. Okay, I have a light bulb here and I'm just gonna hook the light bulb to my little wind turbine here. I'm gonna blow some air on it. Okay, here we go. Whoa. Look how easily that lights up. So now we just have to wire it to our remote control car. So I'm gonna wire it in parallel with the battery. This way it can be charging as it's driving. What it's really doing is adding to the current so that the car battery doesn't use as much power or no power when the turbine is spinning. And I've also added a one-way gate for the electricity so that it doesn't actually try to turn the windmill like it's a motor, but it can only get charged from it turning. Okay, so now to make this mobile, I've hooked up my digital multimeter to it. So I have the battery current passing through this so I can see how much current the battery is having to supply. Okay, now we've got the amps showing right here. This is using 0.03, 0.04 amps. Let's go full speed, go. So it's hanging out right around 0.62, 0.65. Okay, now we're gonna take the turbine off. Okay, no turbine. Okay, go. So you can see that when the windmill is on, it's actually using more power. But how is that the case? The windmill should be adding more power to the car. Well, it's true that it's adding power to the car, but remember that the windmill increases the air resistance of the car. So you can see when I put the windmill on it and blow some air on it and don't have the brakes on, it gets pushed backwards. So the windmill adds extra resistance to the car. That extra resistance causes it to be pushed backwards. So even though you're gaining some energy from the wind, overall you're losing more energy by being pushed backwards.